Okay, hello learning designers. In this video, I'm going to walk through our design vernacular and illustrate it by talking through the Spark prototype project. Hopefully you've watched the prototype project video. One thing that you may not have noticed in the video is that there's a mix of students that participated in that. Some of them are in middle school, grade 8, and some of them are in high school in grade 11. So I'm going to kind of focus on the project as a whole, but it has relevance for all those grade ranges, and that's partly why I chose it. Okay, what I've done is thrown all of our shared, or actually not all of them. I did the first number of the Google Docs that were shared with me, and then the lists got way too long and were becoming really redundant. So I chose to stop with the first several. So if you don't see your ideas on there, it's not because I didn't think that they were the right answers, but rather that I wanted this to be a working document that we could actually review. Okay, so I'm going to walk through the vocabulary and talk about it in relation to the project. Planning backwards is exactly what folks have said here. It's about beginning with the end in mind. That's often associated with Wiggins and McTighe and understanding by design, but it is relevant for all sorts of design work and education. Thinking about what do we really want in the hearts and minds of students and coming back to that all the time, so that we don't get into activity planning where we're planning one activity after the next and forgetting the forest for the trees. And what happens then is we often end up with the kind of planning that is really good at getting curriculum bullet points covered, but not good at students remembering things, not good at the skills and competencies of the program of studies, and also fatiguing as a teacher to plan. The Spark prototyping project used a collaborative design process at the time that's documented here, and I'm going to flip back to here a couple of times for you to see, but knowing that one of the first conversations they had is what in the study is worth whiling over, and the development of big ideas. Okay, authenticity. Lots of great statements here. Connection to real tools, real ways of working, real experts, real problems that are meaningful for students. May or may not involve interdisciplinary learning, but often does because the real world is interdisciplinary. Application is important. Relating to the why, I like this one. A minimum requirement to create a framework for engagement. Without authenticity, you have a real range of buy-in, and it becomes the game of school about the grades, and a whole bunch of students already have figured out what it is that they're getting in the game of school and are not interested in continuing to play it, and or have it figured out exactly how they're going to play it and really aren't learning. They're just doing the thing for the grade because that's what you're making it about. But when you make it real, in the Spark prototyping project, that involved having a chance to exhibit their work at TELUSpark at an exhibition for 1,200 people, or more, thousands of people. It involved having real engineers and other scientists come into their class to work with them on their projects. It involved having access to a whole bunch of different tools, making something that they got to have choice and voice in. All those contribute to the authenticity. Okay, final product. Absolutely, the endpoint, summation, a thing that we're going to share at exhibition. In the Spark prototyping project, they created an exhibit, a prototype of an exhibit. Obviously, they couldn't create the exhibit in the final manufacturing way that is done for the museum, but we had worked with TELUSpark staff to find out how they actually prototype their exhibits, what their exhibit development process is like. Students followed that with mentorship from staff at TELUSpark, and the final product that was exhibited at TELUSpark was a working prototype of a potential exhibit that represented the science that they were trying to get people to bump up against. A good question that sometimes comes up: do we always know what the final product is going to be? The answer is no. Sometimes in project-based learning, the teacher does know. In inquiry-based learning, the project can become more clear after we start inquiring into the inquiry question. And Grayson Adams' talk, for those of you who listen to it, is a good representation of that type of thinking. But either way, Whether or not the teacher began knowing what that final product was going to be or not, it's important to have final products. They become a representation of the learning, a chance for a coalescing of the things that we've learned, a chance to contribute knowledge to the community, a chance to feel proud and realize students made something. So final product plays all those roles. Moving along, big ideas. A couple of really important points here. Linked to the program of studies. Absolutely. If our big ideas need to emanate from the program of studies, the general learner outcomes, they need to represent much of the curriculum, but probably won't be worded exactly like the curriculum. If we look at the grade 8 version of the prototype project, their key understandings were right here. Science is about understanding how the natural world works through systematic scientific inquiry. That's a big idea that could be covered in a lot of different science classes, but one that I'm not sure is often left in the hearts and minds of students. Science becomes about memorizing things that other people have figured out. The other one here, we can apply our understanding of science to solve problems and improve our world. Another huge idea that many of the different programs of study can, different sub-points and general learner outcomes in the program of studies for a number of grades of science actually can play out through that one there. And again, how often do kids get a chance to do this, to see the magic and the importance of science in action and get to be a part of doing that themselves? Okay, so the big ideas can, as people mention here, have multiple disciplines. They can connect to things like competencies or the front matter of curriculum. What I always want to be sure after I'm checking back on a big idea is to think, is enough of the curriculum going to be unearthed through the taking up at this big idea that I can stop worrying about the bullet points of the curriculum and really focus my thinking and design around the big idea. When I come back at the end of the day and I look at what students have done, and if I can see the big ideas, am I happy that I'm preparing them for what the curriculum is asking them to do? If I can say yes to that, it becomes a way of freeing my mind from all the details. I can go back to the details afterwards and see which other ones I need, especially if I'm in a PAT year or a diploma exam year. But otherwise, I feel like the big ideas really represent why the curriculum was put in there, and it connects directly to it. So that's important. We don't always start with the big ideas and then think about what kids are going to make. That creative process can happen kind of at the same time. We're thinking about what the big ideas are, and we're thinking about how those things live in the world. But soon in the process, we want to develop big ideas so that we can make sure that we're connecting to the curriculum and not going down a different rabbit hole that came from the topic in the world but doesn't connect to what we're asked to do in our program. Okay, essential questions. These are, yes, drives other questions and drives the inquiry. It's a way to make the work authentic and get students, gives direction, gets students asking questions, certainly does not require a specific answer. If we look at the grade 8 prototyping project again, the question was, how can we create exhibits that ignite a spark in our visitors? An interesting relationship exists between big ideas and essential questions. This certainly isn't the only question that could help us work towards these big ideas. So this speaks a lot to the authenticity piece, the idea that they had determined at this point that they were going to be creating what they were going to make, create, or do, and how the question then, think of the sub-questions that could come out, things like, well, what makes a good exhibit? What engages people? What does it mean to spark somebody, right? And then from there, sub-questions. Okay, scaffolding. This is the work of designing learning for me. Some people, there's been a misconception that what it means to do project-based learning is to send people off, students off with some sort of a task, and then they come back in a couple of weeks. And meanwhile, the teacher had lots of time to do something else, do the marking for the report card. That ends up with a whole range of work, some of which is unacceptable, others was done in dad's garage and is brilliant, but it's not the learning that we're looking for. The learning that we're looking for to design for as designers of learning is really a product of scaffolding. So manageable steps and chunks working to support all learners to get to the learning that we want them to do, to get to the big ideas, create something they're proud of. How do we go about thinking about scaffolding? For me, it begins with how, if I know what it is we're trying to make, create, or do, like an exhibit at TELSpark, I'm going to ask myself, well, how do the exhibit developers do that? And ask them about their steps and determine how that goes. Then I'm going to work through the project myself, which is something you're going to do, and develop a prototype and figure out what did I need to do, because I'm not a museum exhibit developer. I don't have a degree in museum studies or an associated field. I don't have all the skills. I'm going to need some separate steps to help me be able to do what they do. And then while I'm doing that, I'm thinking, what are the students that I'm working with at grade 8 or grade 11? What are they capable of doing? I'm also thinking about what is their curriculum asking them to do. This is where the bullet points make much more influence on my practice. I might be going back and saying, okay, the curriculum needs them to know these things, so I'll use those as examples, those as skill building. Sometimes scaffolding looks a lot like traditional practice. We're going to do labs. We're going to have skills like how do we develop a good science question, or if it's in another subject area, we might learn how to write a paragraph as a component point. We might do a skill building worksheet. We might read something out of the textbook, but it's about organizing those tasks towards the learning and the big ideas and the product and the authenticity that this is all embedded in. We're going to talk about some specific pieces of scaffolding as we move through this list. Intermediate deliverables. These are checkpoints, things that are submitted during the unit, yes, to provide formative assessment, critique and revision, and also to chunk things for students. Sometimes these are summative in nature. We can glean assessment data from them. Other times they're purely formative. They're going to be built on in the next steps. They are a component of scaffolding. I kind of think of them as when students are going to hand something in, for lack of a better term, and I'm going to need at that point to see what they're doing and give them approval or give them feedback and kind of organize their creative process for them in that way. In the prototype project, they had a number of different steps. They had to have a proposal that got submitted so that they could get feedback from the TELSpark team, an associated timeline and action plan. Without that kind of intermediate deliverable in place, you could see how grade 8 students would not be able to stay on track. Anyway, I won't go through all of them, but that's one example of how they chose to build an intermediate deliverable. After some of the brainstorming work, after the thinking about and visiting TELSpark and understanding what it meant to do an exhibit, etc., they put a proposal in for what theirs was going to look like before they started building and messing around with that whole process. Okay, community connections. We've got a lot of great things here in what you said. Experts, parents, other students, field trip opportunities, resources we can draw on, community or current events. In the TELSpark project, this involved TELSpark itself, their employees, the geophysicists and engineers, and the teachers reached out to the Professional Association of Geophysicists, Engineers, and Geophysicists, I can't remember the acronym, and that's how they were able to get engineers and scientists who are willing to come and spend time in the classroom with kids, and it provided a really neat mentorship opportunity, which we'll talk about later, and a chance for students to see how scientists work and meet a scientist and meet an engineer and have a bit of an opportunity to see what that means and work alongside them, and as opposed to career day where they just come and say what they do it with the students. Critical Friends Protocol is, we're going to model that. You guys got it right here. It's about putting a process in place to support critique and revision, and I'm going to model a bunch of those in our course. Mentorship, we just talked about that. Sometimes this can be other, like reading buddies. Certainly, I think of a mentor as somebody who's kind of if possible, a longer-term relationship with students. So sometimes asking people if they're willing to be a part of the whole project, giving them, I like to give them specific ask. We'd like you to review a proposal pitch. We'd like you to come in and work hands-on with students, and we'd like you to attend exhibition of learning. You're going to do that on Google Docs, then one 30-minute or 45-minute session in the class, and then laying that out for potential mentors is really important so that they know what they're being asked, and they know it's not coming in to do what they saw school being like, do a presentation. They all have the worst nightmares about career day. Often they don't want to do that, but when they see what you're doing and how they're going to work with students, they often really do want to do that. Critique and revision is a huge part of scaffolding. Peer feedback, expert feedback, instructor feedback are all super important, and the revision piece is so important to that. So often in an old model of teaching and learning, teachers would mark up and give a bunch of feedback after a grade was submitted, and the learning is in the revision, right? And the use of that feedback to move learning forward. Formative assessment is an umbrella concept that critique and revision falls into, and all of this fits under scaffolding. I guess what's important in formative assessment, aside from critique and revision, is how it informs the next steps of teaching. How is it that we're collecting evidence to redesign what we need to do next? That's the work of design. Okay, and there was lots and lots of opportunities for the teachers to do that in the prototype project. I'm not going to break them all down. Presentation of learning is kind of connected to exhibition of learning. I think of them as separate. I think of exhibition as at TelSpark, there was thousands of people came to visit the students' exhibits. That's where they're talking about their piece of work to an audience that matters, that drives authenticity, drives engagement, makes sure everybody feels proud of what they've done. Presentation of learning often happens after the fact, although sometimes can be combined. This is where students are reflecting on what they've learned about being an engineer and thinking like an engineer, and what do they take away from that. Often this presentation of learning works in conjunction with portfolios. This is a portfolio is a place for presentation of learning to be housed along with the artifact. It's often organized around competencies. It should have opportunity for students to be thinking about themselves as a learner over time, and a presentation of learning is a kind of a protocol to support students to do that. Okay, I think we've been through all of the vocabulary. Oh, I skipped rubrics. I think you have a strong understanding of what rubrics are. Important note, we're not going to develop rubrics in our project we're doing because that level of detail is going to be too much for us to take on. We have to be careful with rubrics. They're good to co-establish criteria. They're good to guide summative assessment. They can also be limiting in terms of how they box students into their thinking. And you've probably felt that at some times. So certainly a rubric is a way to quantify student work and provide an aim or a target for students. And when used in that way, they're important. Okay, thanks for listening. If you're still listening, we're going to use this vocabulary in the coming weeks and continue to get comfortable with it. And hopefully you can revisit this document and the one you created to support you when you're thinking about these different pieces of the design as we move through our creative process.